All right, in question 3 of 3.5, I wanted to show you a different approach to this question. We would calculate the total energy of the system, realizing that it's always going to be the same. So, kinetic energy and potential energy at any location, the sum of them has to equal the same value. We have enough information to figure this out for one position, where we have m, which we don't know, velocity, which we do know, over 2, plus m, again, same mass, 9.8, change in height is 5. What we get from this is 57 m, where m is mass. At point B then, for question A, it wants to know what is the speed. Well, we know that all of the potential energy that it might have possessed here has been converted to kinetic energy. So the kinetic energy is conserved as kinetic energy, but we have the addition of the potential energy, which is now kinetic energy. So it's simple to say that all the kinetic energy is the total energy, or all the total energy is the kinetic energy. Either way, we know that the kinetic energy is equal to this value. And since we don't know the m and we don't need it, v squared over 2 is equal to g delta h, we can simply say that v is equal to the square root of 2 times 57, and we will get 10.7 meters per second. For question B, we can use similar simplifications. Now that we know 10.7 squared, the kinetic energy without the m, and we know that 9.8, and the height there is 8, the total energy is conserved. Now these two numbers, this one works out to 78.4, the energy required to get over, and this one, 57.2, the total energy of the system. Clearly this is not enough, so it will not clear. It will roll up the hill and back down the other side. How fast would it have to go? Question C. How fast does the roller coaster have to be going at point B to make it to the top of the second hill? Again, total energy conservation. It needs to have a speed of 78.4, total energy of 78.4. 78.4 times 2. Velocity has to equal 12.5 meters per second. Just like that. And we don't need the mass because mass is independent of the energy. In the sense, it's not really independent. It's just that the mass in potential energy is the same mass as is in kinetic energy, and they simply cancel mathematically.